Let's look at a limit calculation. When we do calculus, especially when we finish limits and start discussing the derivative, we have two forms of the derivative that we find useful. Of course, in my class, this one probably found more use because theoretically it was extremely useful. But if we're actually interested in computing the derivative of f at some element c in its domain, we can use this form. That is, the limit as x approaches c of f of x minus f of c divided by x minus c, or this difference quotient form, the limit as h approaches 0 of f of c plus h minus f of c divided by h. These are equivalent, and so we can use this form, which is very popular, or we can use a more elaborate form here. So what I wanted to do, and you know, in a previous problem we actually used this technique when we talked about a limit involving a definite integral. And so what we want to do here is utilize the same technique. So we have the limit as h approaches 0 of 1 over h of the natural log of 2 plus h divided by 2. So again, we have a function of h. And so what we want to do first off, maybe to rig this so it looks like a derivative, is to utilize some of the logarithm identities. So we can actually write the log of a quotient as the difference of logs. So ln of 2h, 2 plus h divided by 2, we will write as ln of 2 plus h minus ln of 2. And now it looks like we're getting to this form. So we'll just move the 1 over h in downstairs and make it look like this. So now we have the limit as h approaches 0 of ln of 2 plus h minus ln of 2 divided by h. And so we have this form exactly, where we see that the function is the logarithm of x, or natural logarithm. So we can appeal to this and just simply write the x derivative of the natural log of x evaluated at x equal 2. And so of course we know that the derivative of ln of x is 1 over x, and evaluated at x equal 2, we get 1/2. It's very important to understand the definitions that we use and to be able to utilize them in situations where they don't seem to apply. But that's one thing about the nature of mathematics. We have to look for patterns so that we can actually utilize what we know. And we are done.